All right, hi everyone. Welcome to the UQ Computing Society's Tuesday talk. Gotta go fast, an introduction to web performance. We have here Rachel from Atlassian, joining us from all the way over in Sydney through the power of Zoom. Today she'll be talking about web performance concepts in industry and how Atlassian developers have used them to choose what to optimize. Rachel graduated from UQ in 2016 and now works as a backend developer on Jira Cloud Performance at Atlassian. So without further ado, take it away.
Awesome. Thanks, Matt. Hey, everyone. Thanks for tuning in. This is super weird doing this remote, but I'm pretty stoked about it. So yeah, thanks for tuning in. Yeah, like Matt said, I've been working on Jira Cloud Performance for about a year now. I've been with Atlassian for about 2.5 years though. So yeah, you already got my background, so we can skip over that. So I will just start off with a bit about Atlassian, seeing as not everyone knows who they are and what they do. But basically, we are one of UQCS's sponsors. We build collaboration tools for teams. So basically, if you need to collaborate with your team on anything, hopefully we have a product for that. So sort of our largest product in that area would be Jira, which is the one I work on, which comes in a few different flavors. But we also do some other ones you might be more familiar with, like Trello, Bitbucket, Confluence Status Page. We also have SourceTree, Opsgenie, and a whole bunch of other things. And we have offices sort of all around the world, kind of. This slide is nice and pretty with all our offices around the world, but really at the moment we only have one, or rather 5,000 of them, which are all of us working from home since all of our offices are closed. I do hope everyone's okay in the isolation world. So today we want to be talking about how fast is my app? And this is maybe a harder question to answer than it might seem on the surface. So I want to talk about page load times, and I want to start off with Slack, because I assume most people here, you're in UQCS, you've probably been in UQCS Slack or used Slack for other things. And so I'm going to start off with that, given I think you might be pretty familiar with it. So how long does it take Slack to load? I have this screen recording here that I'll play for you. If it loads, please load. Okay, awesome. So as you can see, that was a screen recording of Slack just being refreshed, and that took about 5 seconds for it to be sort of fully ready and loaded. So is 5 seconds good? Is 5 seconds bad? Am I just on a bad connection? Other people are going to see different times. And what does 5 seconds for page load even actually mean? Let's take a look at this screen recording of Slack loading again. Okay, so that one was also 5 seconds. However, it felt a bit slower. So you might have noticed that, all the content still came in, at the 5 second mark like we wanted, but you might have felt a bit like this. You might have felt like you weren't sure if the video was playing. Thanks to Google Slides for making video plays weird. But anyway, it just felt like more waiting. So what about another website? Let's try Twitter. Twitter is one of the happiest websites on earth, so I thought I'd go with that. And what does Twitter look like when it's loading? I'll play this. So this is just what the Twitter newsfeed looks like for a regular Twitter user who's subscribed to a few different people, who's following a few different people. And that took about 9 seconds to load from when I pressed refresh to when all the content actually came in. And I should put a disclaimer in here that I have, that is Twitter loading on a deliberately slow network connection, but it's not too far off what we have in Australia, or at least where I am. But let's see what it's like again. This is a slightly edited version. Okay, so hopefully you can see that it loaded. It also loaded in 9 seconds, as you may have guessed, but it felt even worse than Slack's. It felt like you really had to do a lot of waiting around. It wasn't clear if it was going to load or not. And yeah, you got all the content in the same amount of time, but it felt like it took longer. So user perceived performance is actually quite important. And there's a few metrics around that we'll get to. So the breakdown of what the pages actually looked like as they were loading starts off with this blank browser page. It's just a blank white page when you refresh. Then the Twitter logo comes in. Some content starts to get rendered. So in Twitter's case, it starts off with, sort of the navigational settings menu and sort of the tweet bar up the top. It starts bringing in the right bar, which is what's trending, who can you follow, and then it comes in with all the rest of the content. In this case, the actual Twitter feed. In Slack's case, it started off with that blank white browsing page, of course, and the first thing to come in is the skeleton of the sidebar. There's no content there, it's not particularly interesting, but the next frame, it pretty much comes in with everything at once. It's a little bit less incremental than Twitter, but yeah, it comes in with sort of everything at once. It just needs a bit of polish and sort of emojis load at the end, but otherwise most of the content is right there. And I just wanted to put a shout out here because I'm sad that the Slack's custom loading messages have now gone away, but that was a nice era. So the point I'm trying to make is that page load time is not meant to be one single metric, and it shouldn't be one single metric. From the user's perspective, it is a whole experience, whether they are consciously thinking about it or not. So what is our user doing? When they're sitting there waiting for a web page or an app to load, what key cues are they actually looking for? One thing they might want to know is it happening? Like, is my internet working? Is this website working at all? Like, can I get any kind of a response? Is it useful? Is the content that I'm seeing at the moment useful in any capacity? Is it usable? So can I actually do what I wanted to do on this site? And is it delightful? Can I, while I'm doing what I want to do on this site, is it a pain or is it, smooth? So I want to bring this out into sort of a real world example, a physical world example of this. Let's go skiing. Hopefully most of you have gone skiing, but otherwise I'll take you through what a good ski trip looks like. You start off in the car, driving to the mountains, wherever they might be. And even when you're still a long way off, you can sort of see in the distance these snow-capped mountains. And that's when you get the answer to, is it happening? Like, something's happening. There's snow there. You're not worried yet. You're getting sort of more keen. You get closer to the snow. You get closer to the ski fields. You can see the actual quality of the snow on the ski fields. You can see whether the chairlifts are open. You can see if people are actually skiing or not. Maybe how many slopes are open. And that's kind of useful information for you, even though you haven't started skiing yet. So that hits the is it useful metric. Next, you actually put on your skis and you start skiing. And that's what you went for. That's the fun time to be had. And that is when it's usable. And lastly, is it delightful? So what does that mean? In terms of skiing, it means, you can ski around, there's not too many people in the way, the snow's fresh, it's awesome. In terms of websites, it means that you can click around, there's no jank, the animations load smoothly, you don't have to think about it. If you, for instance, press the drop down, it would open up immediately rather than sort of snag and wait a second. But that is what it is delightful is all about. So performance and load times. Load times are not the only thing that matters to performance. From the user's perspective, performance still matters even while they're using the web page that is already fully loaded. So what are these actually called in industry? So the is it happening is what's called first paint or time to first paint. In Slack's case, that was the skeleton of the sidebar coming up. And in Twitter's case, it was them displaying their logo. So that's when you know, like, a pixel has rendered, the server is responding, things are okay for now. And in Twitter's case, I personally cannot load the Twitter website without seeing this almost straight away, which is pretty good for bad internet. Is it useful? So one of the metrics relevant to is it useful is the first contentful paint. So not only has something rendered, but it's something that is useful in some capacity. So with Slack, it's sort of loaded almost everything at once. So you can argue that that's quite useful because now you can actually start reading your conversations. You can see if there's new activity anywhere. You can see if you have notifications. In Twitter's case, it's useful because this first render is useful, arguably, because you can see your notifications. You can open up your settings if you want to. It's maybe not exactly what you came for, but there's content on the page. Something in the dump has rendered. Then we get to the first meaningful paint. And that is when the user maybe actually got something that they were coming for. And this is debatable what it should be on every different website. Every different website has different goals in what it's trying to show users, what users go there for. But in Slack's case, again, it sort of loaded everything at once. So time to first meaningful paint was the same as time to first contentful paint. And in Twitter's case, you can argue that it's meaningful when you can start seeing what's trending. You can start seeing, who you might want to follow, even though your Twitter feed hasn't loaded. And then is it usable? So how long does it take for the site to actually become interactive? If you've been on slow feeling websites, then you might know that, the content loads, but if you try and click on something, it doesn't work. And then you end up rage clicking and you're not sure like what's going on. It just feels slow and unpleasant. So generally this is when sort of everything's loaded, everything's good to go. It's when you can start, in Twitter's case, retweeting, liking, in Slack's case, I don't know, reacting to things, sending direct messages, switching around different channels. Hopefully that's all a smooth experience. So is it delightful? So once the web page is actually loaded, you're actually using it. Is it responsive? Is it smooth? Is there any jank? Those are all, I feel they're all front-end concerns, so I don't know too much about them. I am a back-end engineer. And I would love to see a front-end version of this talk, but we're going to focus on some back-end stuff that we've done in Atlassian. Another random fact is that users expect interactivity at 1.3 times the time it takes for a page to be visually complete. So that comes back to what I said about rage clicking. So once a page looks like it's loaded, users expect that they can actually click on it and interact within 1.3 times the time it took to get to that fully sort of visually complete state. And what that means is you can't just optimize for like, oh. So as I said before, page load time is not one single metric. Hopefully that's come across. But the other metrics I talked about also do not have to be a single metric. For example, time to interactive does not have to be one single metric. And to show you what I mean by that, I'll show you how Twitter's website behaves when it's loading. So just in case you didn't catch that, basically what happened is the Twitter page is still loading, but while it's still loading, and even though there's hardly any content on the screen, you can start typing in that first tweet and actually tweet it out. So Twitter has clearly optimized for the ability to send tweets quickly. And every website, what they want to optimize for should be different depending on their UX, their customer needs. So the question you should ask yourself is, what did the user come here for? And you should think about what your hero elements are. The hero elements are different on every different site. So for example, you want to have custom performance metrics around your hero elements. So in Twitter's case, maybe the hero element is that little box to send a tweet. Maybe that's what they want to optimize for. On a news website, it might be how long does it take just the headline and the banner to load? Everything else can come later. Maybe on a shopping site, it's, how long does it take before that buy button appears and the product name and the product image? Or maybe on a site like YouTube, it's how long does it take for the user to be able to start playing a video? So what my team focused on at Atlassian last year is we wanted to improve the time to the first meaningful paint. So we wanted, from the user's perspective, is it useful? We wanted to optimize that, make it quicker to get to a state where it's useful sooner. So I work in Jira. It's a task tracking tool. And what could go wrong if I do a live demo? I'm going to try and do a live demo of this to sort of show you what I'm talking about. So if you're not familiar with Jira, it's task tracking software. It's sort of like Trello if you've used it. And it's intended for teams so that they can keep track of what everyone's doing, keep track of what needs to be done. So the sort of dummy project I've set up here is from the perspective of a team like the UQCS committee who might want to collaborate on things together and might want to keep track of what they have to do. So what can we do in Jira? I have a bunch of tasks that I've already made. I can add a new column. Let's say that we need a new column called awaiting committee approval. And the committee want to do a joint event with the Board Game Society because they're awesome. But they have to decide on this together. So the sort of core of Jira are these issues, all these little tasks. So let's take a look at this one about deciding on the joint event with the Board Game Society. This page here is the issue view page. So basically, this is one of the most visited pages. It's the most visited page in Jira. It's where you go to see, what do I have to work on, or what is this person working on? And we think that the hero elements of this page are the issue title, decide on a Quags event, the description, so what actually needs to happen, and the status. So, is it done? Is it in progress? What's it like? So if you take a close look while I refresh this, what are the elements that sort of come in first? What are the elements that are loaded first? You can see the title there, the description's there. Let's reload that again. Status is there, sort of this whole right-hand side is here. The comments were not there, the comments were grayed out. These buttons up here, they attach to add child issue, they were grayed out also. Let's take a look. Yep, grayed out, grayed out. The watches button up the top right, this is where you can subscribe to an issue, I suppose, to get updates on it. That doesn't load until after the first render. So that first render is what my team has sort of spent time working on and trying to get faster. And how does it work? I will get into later, but just to prove that it sort of does work, I'm going to add to this labels field here. I'm going to say this is an important ticket. I'm going to say it relates to QGS, and it's fun. Now, if I refresh the page, hopefully that element will come in the first render as well. Yep, there it is. You can see that it takes the pictures, the avatars, a little bit longer to load, but we sort of try and get as much content in on the first page as we can. So from the user's perspective, we hope that this is useful almost immediately. If we take a look at one of the other issues, let's see, we want to book the Red Room for the end of semester. How about that? I'll open this in a new tab for clarity. But you can see on the first render, the image and the emojis sort of take longer to render, but all the text is there. from the get-go. And so yeah, that first render is what we were going for, what we were trying to optimize. So if I jump back into the slides. So that issue view page I was showing, it's the most visited page in Jira. We wanted to give users useful content quickly. So what did the user come for? Like I said before, we think it's the issue summary, the description, the status, and anything else on top of that is a bonus, but certainly the issue summary and description. So phase one of figuring out how to make this fast is to figure out what's taking so long in the first place. So how do we do that? Metrics is one of them. So metrics are sort of bits you can put into your code to say, hey, when we run this function at the start of the function, record what time it is, at the end of the function, record what time it is, and we can see how long that function took. Another way is tracing. So we use a program called Lightstep, but there's a lot of different tracing libraries out there. And basically what tracing is it lets you have a view into what each request is doing in your services. So if you can see, maybe not, but I'll read it out to you. There was a call to, this is just a screenshot from Lightstep. This is not Jira, but in this particular case, there was a call to update inventory. It took 250 milliseconds. But within that 250 milliseconds, as you go further down this page, you can see where that time was actually spent. So this first bit here was about authorizing the user. That's pretty important. But there was a long bit here calling the backend service. Maybe there's something there that can be made more optimal. But yeah, it just gives you a view into that so you can see sort of where to optimize things. We also used flame graphs, which are a view into sort of CPU profiling. Basically, they show you what your CPU is spending time on, what's hogging all the capacity of your service. So it's useful in order to see, like, maybe you have a Java function that's taking stupid amounts of time for some reason. Stupid amounts of CPU for some reason. And maybe there's inefficiencies you can uncover there. So we looked through a bunch of these things and we found the guilty culprit was database access. So basically, whenever we were calling the database to get issue data, that was taking just too long, essentially. It's not that there weren't other places in the code that could be optimized, but this was by far the biggest. So phase two, how do we actually fix it? We sort of had two different options. The first option was to make the database query itself more efficient. And the second option was don't use the database. Try and find a different way to do it. And we actually did both. So the first thing we did was to make the database query more efficient. But once that was done, it was only sort of meant to be a sort of temporary fix while we spent time working on option two. So to answer the question of like, what is it actually like working on performance, at least in Jira, I can't speak for other companies, but you might think it's a bit like fine tuning the engine on a race car. And what I found is that it's more like realizing you're sort of driving along the highway, you're in a normal car, not optimized for speed or anything. You turn around and look behind you and you realize you're carrying like a giant trailer, a giant caravan. And what your job is you need to be able to detach that caravan without stopping and while keeping everyone safe. And so it's a hard problem. We can't just make Jira go down for a day while we migrate people to a better database or anything like that. We have to do everything incrementally. We have to always keep things up and try to improve things at the same time. So with option two, we decided let's not use the database for that first initial render. Let's use a cache. Let's cache all the things. And I apologize if me saying cache or cache bothers you, but I'm going to probably switch between the two all the time. And when I say all the things, I really mean cache some of the things. Like I said, we were focusing on our hero elements, which were, summary, description, status, and the other ones. So what can go wrong when you decide to cache all the things? By the way, I do see in chat that you're wanting virtual pizza. I promise you that's coming. But you can't eat it, so don't get your hopes too high up. So there are two hard things in computer science: cache invalidation, naming things, and off-by-one errors. That's a pretty famous quote, I suppose. But the worrying part in that for us was cache invalidation. So why is it hard? How hard could it be? We're trying to do it in order to show the user up-to-date data. That's the whole point. We don't want to make it fast but unreliable. We want to make it fast and something you can actually count on. So how do you actually update the cache? We use a pub/sub service, which I'll get to in a minute. But for now, or before we did any of this work, what would happen is a user would request an issue from Jira. Behind the scenes, Jira would grab the issue from the database. We use Amazon RDS. It would return us the issue, and we would return it to the user. That was a pretty slow process, but it worked. What we did is we built a new microservice. I'll call it the issue microservice in this talk, just to sort of keep things clear. But what would happen here, just to get that first render of data, is the user would request the issue from Jira. Jira would then request it from the issue microservice, which use memcached to store the issues and retrieve them super quickly, way quicker than the database ever could. And that would get returned up to the user. Dandy, happy. So what happens other times is the user might request the issue from Jira. Jira will go to the issue microservice, and the issue won't be in memcached. Memcached. Come for me, I don't care. So if the issue was not in memcached, what we would do is we would actually have to still make that original call back to Jira's database, get the issue returned, and then go back to the user. So that actually took longer than the original setup of just asking the database straight away. So we had to make sure that our cache had the issues that we wanted it to have often enough that this would not be a problem. So in terms of data invalidation in the cache, how do we do that? So what happens is the user will create an issue in Jira. Whenever you create, update, delete an issue in Jira, Jira tells the database it does the change that it's meant to do. But it also sends an event to our internal service called StreamHub. And StreamHub is a pub/sub service, like I mentioned before, which means we are following the publish subscribe pattern. And what that is you have an event producer, in this case Jira. It produces events like, hey, an issue's been updated, hey, an issue's been created, hey, an issue's been deleted. And anyone who's interested in those events can then subscribe to that event stream and do whatever they want with those events. So our issue microservice subscribes to these events. And we use that to then tell our cache, hey, time to update this thing. And that's how we keep the cache staying fresh. So phase 3 was to monitor, like, did we do a good job? Like, what is our actual cache hit rate? What are our news speeds? Has user happiness gone up? We spent a lot of time working on this, making this service reliable. There was a lot going on behind the scenes, but ultimately the answer was yes. We did improve that first render of data quite a bit. And now we are working on improving the full page load time, which is going to take a lot longer for us to do. But we're pretty happy with what we achieved. It was relatively quick win, like it took us, several months, but in the grand scheme of things, the issue view page gets loaded all the time, and it's pretty cool that we cut back the time it takes to start seeing useful content. So in terms of, do algorithms matter? I haven't mentioned algorithms yet, but I did want to address this because I do run interviews for intern and grad candidates at Atlassian sometimes. And I have had 3/4 of the candidates I've had this year ask me if the algorithms even matter, which is an interesting question. So in terms of whether I have specifically used them on my job, yes, but not in the ways you might think. So I have never had to balance a binary tree or write my own sorting algorithm. Absolutely not. Not to say that other people don't, maybe they do. But it is important to have some knowledge, a lot of knowledge on data structures. I'll just say that up front. Data structures, very good to know. But in terms of algorithms, it is important to be able to understand how your code scales with input, but not exactly in the ways you might think, or at least not for us. So if you take a look at these 2 code paths, obviously this is pseudocode. Option 1. So you have some operation to do on issues, let's say, a group of issues, a list of issues. In option 1, you loop over every issue, you get that issue from the database, you process that issue in whatever way, in this case, maybe an update. You add the issue to a list and then return that list of issues. Pretty simple, right? In option 2, it's slightly different. You get all the issues from the database first. You then loop over them and say, for each issue key, do that processing, add the issue to the list, and then return that list of issues. This is a pretty contrived example, but it's not too far off a lot of the code that I've encountered. So what's the difference between these two? In terms of an algorithmic mindset, if you were asked in a technical interview, like how does each scale? You would say O of N for both, and you would be right. But you need the knowledge of how to analyze how code runs in order to realize that in this option 1, getting an issue from the database scales with N as the input size. In option 2, calling the database is an O of 1 operation. You only do it once for every request. And in our case, database access, super slow. We try to avoid it as much as possible. And therefore, we would absolutely preference the second option every time. So it's not directly like the algorithms that you might be familiar with, I suppose, but you absolutely do need the knowledge. It comes in handy for sure. Yeah, so in terms of job opportunities, if any of this has inspired you, Atlassian are hiring a whole bunch of grads and a whole bunch of interns. I believe the numbers are like we want 100 and something grads and 100 and something interns, which is absolutely crazy. We are still hiring amidst the coronavirus outbreak. We're actually doing all interviews remotely, which means that none of our Sydney candidates coming into the office. And personally, I think that's awesome because everyone gets a remote interview. Yeah, we're hiring software devs, product managers, site reliability engineers, content designers, security engineers. Those are for a January start next year. Interns are available to anyone in their penultimate year of university. And I would really recommend applying. So if you have applied before, definitely feel free to apply again. It's, everything, a lot changes in a year as we've noticed over this past month. So on the premise of virtual pizza, I am going to give you virtual pizza. I wanted to talk about something that I like about Atlassian because I could tell you about our, like our internal hackathons and I don't know, whatever else, but something that I really like about the company is that we have an internal culture of sort of learning and sharing our learnings. I wanted to show you a blog that sort of encapsulated that. And I'm allowed to show you this one because it has no technical secrets in it. So this is a blog by our very own Aiden, who is Sladen on Slack. And he learned something at work and he made a blog about it. He called it the greatest lunch in the world. Basically at work, we have this setup of like sort of a salad bar for lunch. And I don't know, sometimes people get bored of the salad bar, but Aiden was creative. Basically, he took one of the wraps and then a bunch of the cold meats and cold cheeses, and he made a pizza. He put it in the sandwich press, and it was a glorious sight to behold. But like any of our internal technical blogs, it got some traction. A lot of people liked it. A lot of people learned from it. Oh, I don't want to show you anyone's names. 235 people liked it. And we were all better off for it. So yeah, my point there being, Atlassian is a culture of learning. It's a culture of sharing. It's a culture of bringing everyone up, whether they're grads or whether they're architects. And it's a pretty cool place. If you do have any questions about anything, chuck them in the chat. I'll try and read along. And also, I'm on Slack. I am Ratchcatch. There is also Joe, who was an Atlassian, who is here with us. He is Spirit on Slack. Oh, I see a question is, if you're a third year out of a 5-year degree, you can't apply. No, we do only take students in their second last years. Okay, there's another question. It's, couldn't you send the request to both at once and then discard? Yes, we can. We actually do that as well. I did give you sort of a simplified version of what we're doing in the service. But yeah, we do shoot off parallel requests, one to the database, one to the issue microservice, and then whichever one comes back faster, we return that. It is consistently the from the cache, though. And we didn't start off with parallel requests, but that is an improvement that we made. Are there any roles based in Brisbane? No, sadly not. It is all Sydney and abroad. I wish there was. We do have some remote roles sometimes, but generally speaking, they're not really for grads and interns, sadly. But yeah, Sydney's awesome though. You should get in on it. What are top 5 must-know algorithms in your opinion? Oh, that's a good question. I don't think I have a top 5. I feel like there's a top 5 data structures you need, which would be like, I don't know, hash maps, hash everything, linked lists. I feel like that's a really hard question. And it probably depends quite highly on what you're doing. Do you have any advice for people going through the Atlassian interview process? Yeah, my advice generally is to ask questions in Slack because there'll be plenty of people there to help you out. But otherwise, there are several stages to the Atlassian hiring process for interns and grads. It is the same process. So basically, you start off doing an online HackerRank test. That's the first step. I would recommend like you practice some sort of beginner and intermediate HackerRanks before doing that. You don't need to put too much pressure on yourself. But yeah, that's just something small I recommend there. When you progress past that stage, you do get 3 interviews, which are, one of them is a coding interview. It's kind of similar to the HackerRank test, but it's more about you being able to explain what you're doing while you're doing it. We want to see your communication skills, your thinking process. We do test to see, if you can analyze like how your code scales with the input it receives. But hopefully it's nothing too scary, but yeah, getting some practice in there is good. The other 2 interviews, one of them is values based. So Atlassian does have 5 values that you can read up on. They're pretty simple. And that's more a behavioral interview style interview where we will ask you questions about like things you've done in the past, and then we sort of get an idea of how you respond to situations. The third interview is a sort of oh, how do I describe it? I'm going to butcher it. We ask you to talk about a project that you've done, whether it's a uni project or something at work or like a side project, anything. We get you to talk about what you did there, and then generally you'll be asked on sort of why you made certain decisions, and how you worked in a team, or whatever is relevant to that project. Um, so Atlassian help with finding accommodation. Um, I don't know. I feel like that answer changes all the time. You do get a relocation bonus if you do get a grad or intern position. I don't believe they offer direct assistance with finding accommodation. Um, I don't believe so. I'll say I don't believe so. There is a relocation bonus, however. Oh, is there an event where you can practice interview style questions? That actually has been quite requested. We should probably do something like that. But UKCS committee can say if there's an event where you can practice interview style questions. Tabs or spaces?
Oh wait, sorry to interrupt. Hello.
Oh yeah, go
Just
for it.
shilling the code jam that's on this Saturday. That will be a HackerRank event, and you can practice your interview style questions there, and that's in partnership with Atlassian as well. So
Yes, absolutely. Code Jam Saturday. Like I said, yeah, if you are going for Atlassian, it is good to get in some HackerRank practice, and that's exactly what the Code Jam on Saturday is meant to achieve. Tabs versus spaces. My answer to that is very boring. I don't think it matters. I think just pick a style, whatever it is, run with it. Your IDE should be able to handle whatever you throw at it. What is the best bit about working at Atlassian? Personally, I think it's the sort of teamwork aspect and the learning aspect, basically just the culture. So I started there as a grad. I felt like I knew nothing, still feel like I knew nothing, to be honest, but everyone there is super supportive. They give you, like, you have a budget, an education budget that you can spend on things like, conferences or classes, to help you get better. Everyone there is so supportive. In terms of teamwork, I think it's really cool that, like, there is a dedicated person on every team at any given time whose job it is to, like, answer questions that other people in the organization have about their team or their responsibility area. And as someone who finds it, like, hard to go up to someone and interrupt them and, like, ask them something, I think that's super valuable because it just helps teamwork get done faster. um, I might just wait a minute to see if there are any more questions. I think I have answered them all though. Question for the audience is, have you tried to make any crazy pizza concoctions, given that you're all stranded at home? Although you're probably not stranded at home. I don't know, is Yuki still letting people roam about? Probably. Oof. Okay, I think we're done on the questions. So I'm gonna wrap it up. Thank you so much for tuning in. If you have any further questions, definitely hit us up on Slack.
yeah.
Oh, there's a question about Sydney that I will answer. But otherwise, UKCS is hosting an industry panel on Thursday night that Atlassian as well as some other companies are attending, and the Code Jam on Saturday, which I recommend everyone attend as well. Do we enjoy living in Sydney? Heck yeah, Sydney's the best. So I love Brisbane. I love Sydney. I don't think we should fight. Personally, everything I like about Brisbane, Sydney also has. Like, what I enjoyed about Brisbane personally is you can jump in a car, drive an hour and a half in any direction, and just be somewhere beautiful, like the mountains or the beach or something like that. It's no different in Sydney. Now there's just new places for me to go, I guess. But I love the city. The public transport's great. The work's great. Probably my favorite thing about Sydney is the culturally different backgrounds of all the people. Like, I worked at a few different places in Brisbane, and they are full of people from Brisbane, which is fine. Like, Brisbane people are awesome, don't get me wrong. But it's just so different in Sydney. Um, like the people on my team are from Germany, Poland, Russia, Chile, New Zealand. Oh, I don't even know one of them. I'm probably going to get it wrong. Australia, China. Like, it's crazy. I just really love that aspect of it. All right, cool. Enjoy the night. I'll hang around on Slack for a bit, but yeah, otherwise, thanks for tuning in.
Yeah. Thanks so much, Rachel, for joining us tonight. I would give a mug, but I can't do that over Zoom. But hopefully when this COVID stuff settles down, we can deliver on that promise. Thanks for watching, everyone. This is actually our first Zoom stream, so we appreciate your patience as we fiddle with the stream a bit. Our next event, as Rachel mentioned, will be 6 p.m. on Thursday night, the industry panel featuring Canva, Atlassian, IMC Technology One, and Vivian Court Trading. We hope to see you there. As always, you can find more details about it on our Facebook page. And we also have our Code Jam with Atlassian on Saturday from 10 a.m. till 3:30 p.m. And we'll have more details coming very soon. So yeah, thanks for joining us, and we will see you next time. Bye-bye.